Welcome back to my new lecture, dear friends. As in the earlier lecture we discussed about the damped vibrations. Today in this lecture we will talk about the amplitude of forced vibrations. It is the most important topic as far as VTU examinations. Okay, so 8 marks question, definitely they will ask it. It is the frequently asked question in the VTU. Okay, so let us discuss it. First, let's try to understand the difference between damped vibrations and forced vibrations. In the damped vibrations, as I earlier mentioned in the previous video, that when you are considering a body of mass m executing vibrations in a damping medium, there acts two forces, resistive force and resultant force. Okay, or resulting force, you can say that, or restoring force. Okay, so in this particular type of vibrations, as the name itself says, the forced vibrations, you are forcibly making vibrations with the help of external force. Okay, so consider a body of mass m executing vibrations in a damping medium acted upon by an external periodic force. So you are externally giving it a force, that is periodic force, external periodic force, by which it continuously vibrate, okay, in the system. Eventually in the particular damped oscillations or damped vibrations, the body comes to rest, but in this forced vibrations, so here continuously the periodic force is acting on the body over here. Okay, so that periodic force is given by F sine of pt, where p is the angular frequency of the external force. So only difference is here the periodic force is acting, and also these resistive and restoring force are also acting in this particular system. So it was in the damped oscillations also. So as you already know, as far as that video is concerned, so I have told you the force, restoring force or resistive force in the damped oscillations, that is r into dx by dt. Okay, where this r is the damping coefficient, and you have to take the negative direction of it. Okay, as it acts opposite to the body of the opposite to the motion of the body. Okay, as this r is equal to, where r is equal to damping constant. Okay, and dx by dt, you already know it is the velocity over here. Okay, this is the one force, and another is restoring force. You already know restoring force is equal to minus times kx, and where k is the constant over here, so k is equal to proportionality constant, and this x is equal to displacement. Now how many forces are acting in this particular medium, damping medium? One is the periodic force, that is F sine of pt. Another one is r dx by dt, where this r is the damping constant and dx by dt is velocity. Okay, fine. Next one is minus kx, which is the restoring force. So resultant force I can write here, resultant force is equal to summation of these three forces, that is F sine of pt plus, but it is minus here. Okay, so I can write minus r dx upon dt and minus times kx. Okay, this is the resultant force for this particular system. Now as per Newton's law, okay, Newton's second law, as per Newton's second law, what it says, that resultant force is equal to mass into acceleration, that is rf is equal to mass into acceleration, means d square x upon dt square. Already in the previous video I mentioned it. What is the acceleration is equal to d square x by dt square. Okay, I can write it as second equation. So this was our first equation. Okay, write down as first. Then we can write down, instead of this resultant force, here is also rf, so left hand sides are equal. I can write down the right hand sides are also equal. If left hand sides are equal, then definitely right hand sides are also equal. So I can write this m d square x upon dt square, which is equal to, I will write down first this term r dx upon dt, then minus times kx, then plus f times sine of pt. I hope this is clear, my dear friends. So always remember, my dear friends, whenever the left hand sides of an equation of two equations are equal, then right hand sides we can easily compare. Means this side will definitely equal to this side. Okay, that is what I have written here. That is md square x by dt square is equal to this term over here, right hand side. Now I can just transfer these negative terms into the onto the left hand side. So md square x upon dt square, which is plus or dx upon dt, plus kx, which is equal to f sine of pt. So this is another equation. Okay, so this is, you can write down this equation as, so this is the equation of motion, this is equation of motion for forced vibrations. Okay, so for forced vibrations, fine. Now divide this equation, that is equation of motion for forced vibration, divide this whole equation by m. Okay, when I divide this equation by m, so m and m gets cancelled, so it will become d square x upon dt square, means I am dividing m by m here. Okay, m by m will get cancelled, plus r upon m dx upon dt, plus k by m sorry, x here. Okay, so f by m sine of pt. This is, I am doing I am dividing the m throughout the equation over here. Okay, so we will get this equation where this r by m is equal to 2b. So I can write here r by m is equal to 2b, and this k by m, this is x, k by m is equal to omega square. As in the earlier lecture also I mentioned it, these two terms you have to remember here. So r by m is always equal to 2b, and k by m is equal to omega square, that is natural frequency. Now this equation, suppose if I am writing it as third equation, so it can be rewritten as, now d square x upon dt square plus r, instead of r by m there is 2b, so 2b dx upon dt, plus instead of k by m I can write omega square times x is equal to f by m sine of pt. Okay, fine. So this is our differential equation now. So as you already know, there is always a solution for a particular equation. So this is a differential equation of second order, so it has its solution, which is given by the solution of, you can write the solution of given equation, that is above equation, I can write it as 4. So fourth equation, the solution of it as x is equal to a times sine of pt minus alpha. This is the solution for it. Okay, I can call it fifth equation, where this a and alpha are the unknowns, which we have to calculate, which have to we have to found, so to be found. Okay, a and alpha are the unknowns which we have to found. Okay, let's find it. So in order to find a and alpha, dear friends, this equation is the simple harmonic motion. Okay, so let us differentiate it first in order to get the values of a and alpha. So I am differentiating here, differentiate equation fifth. Okay, with respect to t, twice you have to differentiate. Okay, so I am differentiating here dx upon dt, that is this equation I am differentiating. Okay, remember it, dx upon dt, which is equal to a times this is sine. What is the differentiation of sine? The differentiation of sine is cos. Okay, so I can write here as cos of pt minus alpha, and internal differentiation of pt, so that will become p only here. The differentiation of t is 1, so I can write p outside, so this will become ap cos of pt minus alpha. This is your sixth equation. And next I am again differentiating it, this equation I am again differentiating, so I will get d square x upon dt square, which is equal to, what is the differentiation of cos pt minus alpha? Minus sine of pt minus alpha. This is the differentiation of cos. Okay, and a is already here and p is already here, and internal differentiation of this pt is p. Okay, that p will get multiply here, so you will get d square x upon dt square is equal to minus times a p into p is p square sine of pt minus alpha. Okay, so this is your differentiation for second differentiation for it. Okay, I can call it seventh equation. Now substituting equation 6, this equation 6 and 7 these two equations you have to put in the equation fourth, that is this equation, d square x by dt square, d square x by dt square you are getting here. So this value you have to put in this particular equation, and instead of dx by dt you can write down this value. So let me put it now. So substitute equation 6 and 7 in equation 4th. Okay, the values in the 6th and 7th I am putting it in the 4th equation. You should have a look on it. 4th equation, what is it? So d square x by dt square, I can write down this value. Okay, that is minus times ap square sine of pt minus alpha. Okay, this is the one part. Then plus 2b is as it is. Then instead of dx upon dt I can write this value, dx upon dt is equal to ap times cos of pt minus alpha. Okay, rest of the things will remain same in this particular equation, that is plus omega square x is equal to f by m sine of, this is f by m sine of p into t. So this is your equation after substituting the equation 7th and 6th in the equation 4th. Okay, I will call it now 8th equation. It is a little bit lengthier one, my dear friends, but a little bit operations are there. It is a very simple question, but steps are more in this problem. But it is a 8 marks question which will be definitely in the VTU examination, so you have to focus on and stay tuned with me till end, so that you will understand this concept very well over here. Okay, now I can just what we call the right side of the above equation can be written as the right side, that is f by m sine of pt. I can write it as, if I just modify it, I can write the right hand side, that is f by m sine of pt. I can also write it as f by m sine of pt minus alpha plus alpha. Okay, if you just plus minus it, it will become 0, so you will again get the right hand side of the above equation. Okay, this you are getting after modifying the right hand side. Okay, now if you substitute this this value f by m sine of pt minus alpha plus alpha in equation 8th, okay, I will just put it this right hand side value in the equation 8th again. Okay, I can write it as which will be equal to minus ap square sine of pt minus alpha plus 2b ap times cos of pt minus alpha. Okay, plus alpha square x is equal to, now I had to write instead of this value as this particular value. Okay, that is f by m sine of pt minus alpha. Okay, plus alpha. Why I just modify it? Just because pt minus alpha I was supposed to get here as in the early in the previous terms. You can observe here pt minus alpha, and now pt minus alpha. That is why I made this move over here. Now let me simplify this equation, dear friends. I can write it as ap square, which is equal to ap square minus times ap square sine of pt minus alpha. Okay, this is same as it is 2b ap times cos of pt minus alpha plus omega square x. So instead of x, you already know here in this particular equation x is equal to a sine of pt minus alpha. I can put it here as ap a times sine of pt minus alpha. Okay, so x value is a sine of pt minus alpha. I am writing instead of x here as a sine of pt minus alpha. Rest of the things will remain same, so this will be equal to f by m. This is now formula sine of a plus b. Sine a plus b is equal to sine a cos b. Sine, what is sine a? A means pt minus alpha. Okay, sine a cos b. Cos b means cos of alpha. Okay, plus cos a sine b. Cos pt minus alpha and and sine b means sine of alpha. So this is your modified equation after putting the formula here, sine a plus b, which is always equal to, you can remember here, sine a plus b, which is always equal to sine a cos b plus cos a sine b. Hope it is clear. Now comparing the coefficients of this sine pt minus alpha on both sides. Okay, here is also a sine pt minus alpha and cos pt minus alpha, sine pt minus alpha, cos pt minus alpha. You have to just what we call as equate the coefficients. What is the coefficient of pt minus alpha here, which is equal to, you can write here in the above step, comparing coefficients, comparing coefficients of, so comparing coefficients of sine of pt minus alpha. Okay, so I can write here as minus ap square is the coefficient of sine pt minus alpha. Let us have a look. Another sine pt minus alpha is here, so it is plus omega square a, and on the right hand side sine of pt minus alpha is here, so what is the coefficient of it? That is f by m cos of alpha. You can write the coefficients of it. Okay, so this is your ninth equation. Okay, ninth equation it is, as we are getting here as eighth equation, it is ninth equation. Now similarly I can write, similarly comparing coefficients of cos of pt minus alpha. Now you have to check the coefficients of cos pt minus alpha. Let's have a look. So cos of pt minus alpha is here. What is the coefficient? So it is 2b times ap, 2b times ap. Okay, another cos of alpha is not here. Now have a look on the right hand side. Cos pt minus alpha is here, so what is its coefficient? That is sine of alpha. Let us call it as 10th equation. Okay, so it is 10th equation. Now another step is, dear friends, squaring and adding, squaring and adding equation 9th and 10th. Means you have to what we call as write down the two steps here, that is squaring and adding equation 9th and 10th. I am doing firstly the square over here, so I will get minus times ap square plus omega square a, so I will just square it, square of it, square, and then which is equal to, and randomly you are adding this particular term, that is 2bap, that is plus 2 times bap whole square is equal to f by m cos of alpha whole square plus sine of alpha whole square. Okay, this is your whole this particular step, that is squaring and adding equation 9th and 10th. You have to suppose first take the squares of these terms, then you have to add this 10th equation, and then accordingly you have to do the square of this 9th equation and adding 10th equation over here. Okay, so I will get here as a square omega square minus p square after simplifying it. Okay, plus 4 times b square p square, that is 2 to the 4 b square, and this a and p I will take out as common in this particular terminology. A I will take common, that is why I take a square here, which will be here as m by f by m, and this cos square alpha and sine square alpha, you might be knowing this is always equal to 1, so I can write here as f by m whole square, only f by m, just because cos square and cos square alpha plus sine square alpha is always equal to 1. Okay, so this square and this square will get cancelled. I will get the a term here, so a is equal to, this is f upon m whole divided by, when I just transfer this term into right hand side, so I will get it as under root of, so I can write down under root of this 4b square p square plus omega square minus p square whole square. This is your 11th equation, and it is the equation for the amplitude. Okay, after simplifying it, so what I did here, my dear friends, I just take a square as common. You can see here a into a square, a square is also here, and also here a square, so I just take a square as common, then rest of the things are same, omega square minus p square plus 2 to the 4 b square p square. Okay, so which is equal to f by m, and cos square alpha plus sine square alpha is always equal to 1. Then after simplifying, a is equal to f by m under root of 4b square p square plus omega square minus p square whole square. So this is your equation for the amplitude. Okay, so if you have to calculate displacement now, okay, so I can write here substituting substituting equation 11th. This 11th I have to put in equation 5th probably. Let me check it first. So this is the 5th equation. Yes, exactly. So this is the 5th equation, dear friends. That is x is equal to a sine of pt minus alpha. Now I will just put this a value which we are getting here. So this a value I will put in this particular equation, x is equal to a sine of pt minus alpha. So I will get displacement value as x is equal to f by m under root of 4b square p square plus omega square minus p square whole square. So I am getting the displacement to x is equal to f by m under root of 4b square p square plus omega square minus p square whole square by putting a value in the 5th equation. So this is the whole question, my dear friends. It is long but simple. If you just remember the steps, if you just focus on, if you just try practice at least 2 or 3 times, so that you will remember it for your examination purpose also. Okay, so thanks for watching the video.